Hi, I'm Bob Tabor with LearnVisualStudio.net. In this lesson, we're going to write the code that's required to record the custom sound. So we're going to employ the Coding for Fun toolkit to help us make this a lot easier. However, we still are going to have to come to a fundamental understanding of some things like memory streams and buffers and the phone's isolated storage. So this will be a challenging lesson. I'll speak more about that in just a second here. Our game plan in this lesson is that we're going to modify the toggle button, the record toggle button, and we're going to wire up event handlers for the checked and the unchecked events. So turn it on, turn it off, okay? Then we're going to use the microphone record class in the Coding for Fun toolkit's audio namespace to begin and stop the recording process. And then we're going to look at what happens after we stop recording. We're going to need to temporarily save the sound that's stored in the phone's memory to a location on disk so that it can be played back via a media element, and then also it can be saved permanently so that the user can continue to use that sound from this point on. So the fourth thing we'll do is add a media element control so that we can play back the sound, the temporary sound, and the user can decide whether to keep it or not. And then finally, we're going to manage the state of that play button. I mean, after all, we don't want to allow somebody to click the play button during record. We only want to allow the play button to be enabled when the record button is not currently depressed. All right? So let me just say that this is perhaps one of the most challenging lessons in this entire series because it will deal with some slightly more advanced material. You should embrace this. You only learn when you struggle, and challenging yourself with difficult concepts will help you grow faster. So be sure not only to watch this video, but also read the MSDN articles that I reference throughout so that you get a full background and you understand these ideas as you're working through them. So put on your thinking cap and let's go ahead and get started here. The first thing I want to do is edit this toggle button. So we're going to edit our XAML, and what I want to do is just add event handlers for the clicked and the unclicked, or the checked rather and the unchecked state of the toggle button. That's why we chose a toggle button in the first place. So here in the toggle button, I'm going to go checked equals, and I'm going to go ahead and give it a name myself, record audio checked, and then unchecked equals record audio unchecked. Okay. And now let's go ahead and just right click and navigate into that event handler. And we'll go ahead and do the same for the other one, so it creates the method stub for each of them. Great. All right, so the next thing we're going to need to do is work with the microphone recorder in the Coding for Fun toolkit. And what we'll do is we'll be using it throughout this entire page. And so I'm going to create a private member variable that'll hold on to the reference to our microphone recorder. So microphone recorder underscore recorder equals new microphone recorder. All right, and you can see that we don't yet have that namespace in our using statement. So let's go ahead, click the little blue line that's under the capital M in microphone, and I want to add the using Coding for Fun toolkit.audio namespace, and that should clear that up. Great. Okay, so we have a new private instance of the microphone recorder class. The next thing we'll want to do is simply go here to our record audio checked, and we're going to start the recording process. So recorder.start, and then recorder.stop. Is it that easy? Well, yes and no. I mean, there's a lot going on behind the scenes here. But now that we've stopped recording, we have to do a little bit of manual work. Fortunately, a lot of the complexity has been taken care of for us. Now we just have to decide what to do with the data that we've recorded. So as we're recording, the microphone recorder object is collecting the sound information in what's called a buffer. A buffer is simply a pocket of memory that's devoted to storing data on a temporary basis. Buffers are typically used when there's a difference between the rate at which data is collected or received and the rate of speed at which it can be processed. All right, so it it may take us 10 seconds to record a 10-second sound. During that time, data is being added to the memory buffer. However, the computer could process that data in a fraction of a second. So the buffer is just a queue. We can write the data at one rate of speed while reading it back at another rate of speed. In programming, buffers usually go between physical hardware and software, or when moving data from memory to disk and from disk back to memory. Or data is coming from memory and going out to a network connection, or data is coming from a network connection and then it'll be retrieved into memory and used in some variable. Okay, so I'm not a computer science guy. I don't understand all the inner workings of how buffers work and why they're needed and all that. All right, so I just tend to think of a buffer as a bucket that you slowly collect things into until you're ready to work with the entire bucket at one time. So, all right, this is a silly example, but hopefully you'll get the idea. I'm walking along the beach and I'm picking up shells and I'm putting in my bucket. All right, and I spend an hour finding shells. But then once I get a full bucket, I want to start processing them, deciding which ones to keep and which ones to throw away, and that'll happen very quickly. So I collect data over a long period of time, and then once I've filled up my bucket, I then process it very quickly. All right, so at least that's how I think of a buffer. Maybe that'll help you out a little bit. So anyway, when we call the stop method, the microphone recorder stops adding sound information to the buffer, but it's holding that information, that data, in the memory buffer. And now we need to process the data in the buffer. So in this case, I use the term process to mean that I want to grab the sound data out of the buffer and I want to place it in a temporary file, a WAV file, on the phone's permanent storage disk, I guess you could say, this permanent storage area, all right? So once it's sitting on my phone's storage, I'll be able to hand that file over to the media element and say, hey, play this, so that the user can hear what the sound that we recorded actually sounds like, all right? So if the user then wants to keep that file, I can rename it and then store it in a different spot permanently. So let's talk about storing files on a Windows phone. The storage space on the phone is partitioned into isolated areas. Each app installed on the phone gets one of these little tiny slivers of all of the storage available on the phone. Now, I use the term isolated because one app can't look at the storage area that belongs to another app. This is for security. One app can't just rummage through your photos or your notes or other secret data and then uploaded to some secret malicious server or corrupt it in some evil way, okay? So this isolated permanent storage area that's dedicated to your app is called isolated storage. It's just a tidy way of keeping each app's data safe, since each app is only able to write and read from its own little storage area, okay? So back to the problem at hand here. The microphone recorder object has a bunch of data now. At this point, right here, when we call stop, it has a bunch of data sitting in a memory buffer, a memory stream object, and my job is to save that data from the memory stream object to a file, a temporary file, in isolated storage. To accomplish this, I'm going to create a helper method that will take a memory stream as an input parameter, and then in the body of that little helper method that I'm going to create, I'll create a new file in isolated storage, and then I'm going to dump all of the memory stream buffer data into that temporary file. All right, so that's the plan. So let's go ahead and start building it here. I'm going to create a new private method. So private void save temp audio. That sounds good. And what were we going to use as a input parameter? The memory stream object, because I happen to know that's what is being used in the microphone recorder and what we'll be able to retrieve out of the microphone recorder, and ultimately we want to save to disk, or to the isolated storage rather. Okay, so as you can see, I know we're going to need this memory stream class. However, it's not in our namespaces. It's in the using system.io namespace, so we'll add it like that by hovering our mouse cursor over the little blue cursor under the M and then choosing the correct using statement. All right, so now that we have that, we're going to employ a different kind of using statement. You may have never seen this before, but it has a very important purpose, especially as we're dealing with unmanaged resources like the isolated storage area on the phone. Okay, so here we go. Okay, so there we go. Now, in this context, this using keyword will create a context for an instance of this class. Now, let's find it here. It's actually in the system.io.isolated storage namespace. Let's go ahead and add that. Okay, so it'll create an instance, a context for an instance of isolated storage file. So this ISO store variable. Any code inside of this block that's defined immediately after the using statement will have access to this ISO store variable. So, but once the flow of execution leaves that code block, the ISO store variable will no longer be available because it'll be disposed from memory properly. Now you use this using syntax when you want to work with classes that implement an interface called iDisposable. Now typically these are managed types in the .NET base class library, or in our case the Windows Phone API, and those classes, those managed classes, access unmanaged resources. So the primary use of iDisposable, of the iDisposable interface, is to release unmanaged resources that are no longer needed. So the garbage collector automatically releases the memory allocated to a managed object when that object is no longer used. However, it's not possible to predict when garbage collection will occur. Furthermore, the garbage collector has no knowledge of unmanaged resources such as Windows handles or window handles or open files and streams. So the danger is that two or more processes or two or more apps, okay, they attempt to access the same resources at the same time and cause an unrecoverable error condition. And basically, in this case, crash the whole phone. So types that implement iDisposable handle these scenarios correctly, and that's all that we really need to know. But for a more complete explanation of these topics, I strongly encourage you to learn more about the using statement and the iDisposable interface. So take a look at the MSDN help for both of these. They're well-written articles, and then use that as a starting point. Don't just stop there. Read more articles about iDisposable and why you'd use it, especially in this scenario, and what the using statement helps you to accomplish. We're working with this isolated storage file type called ISOStore. And the isolated storage file class provides methods that help you manage the files and the folders for use by your app in isolated storage for your particular app. Okay, so we use this get user store for application method to retrieve the isolated storage area just for our app so that we can work with a file that will sit inside of isolated storage for our app. All right, so the next thing we're going to need to do is grab the buffer that has been passed in a memory stream and attempt to create a file in our isolated storage area and dump the data into it. All right, so let's do that next. So here we go. I'm going to call this var bytes. It'll indicate the zeros and ones that are stored in our memory stream that we want represented as a WAV file. Okay, so we're going to use buffer dot, and I want to use this method called get wave as byte array. Okay, the intent of this line of code is to retrieve values from the buffer and convert it into the format of a WAV file. Now, as you can see, the memory buffer doesn't implement this method just yet. What we'll want to do is use an extension method from the Coding for Fun toolkit.audio.helpers namespace. So in order to apply this extension method, we're going to add another using statement at the very top of our code. All right, so let me just go ahead and copy this and go audio.helpers. All right, so there we go. And so an extension method in .NET allows you to attach a method to any data type. So I could add some utilities to the int data type or the string data type, or in this case, the system.io.memorystream data type. So an extension method allows you to work with the members of that type, just like any other public method that was properly defined inside of that class. But we're just bolting another method on the side of an existing class is essentially what we're doing. That's the purpose of an extension method. All right, so let's see. And now it sees it, and it sees that we don't have it called quite correctly. So let's give it what it wants, and that is a sample rate. So we're going to give it recorder dot sample rate. Okay. So this is one of those spots where I'm just trusting Clint's understanding of what it takes to convert the memory stream into a WAV file. We have to pass in the sample rate, which is the number of samples of a sound that are taken per second to represent the sound digitally. The more samples, the higher quality the sound, but also the more data that you have to save and the larger the sound file. So here we're just going to pass in the default sample rate for the microphone recorder and then let Clint's code work its magic. For more information about extension methods, take a look at this MSDN article on screen right now. And please note that this is an advanced topic. As long as you understand what extension methods do and what purpose they serve, that's really enough for right now. You can learn later on how to create your own. Okay, so now we have the buffer as a WAV or audio format in this variable called bytes. We just need to actually put it into a new file on the device's isolated storage area. So let's do this. Let's get up here, and I'm going to first of all create a file name for our temporary file. So var temp file name equals tempwave.wave. We may come back and revisit this a little bit later, but for now this will work. All right, so we want an isolated storage file stream called audio stream equals isostore dot create file temp file name. All right, so we're creating a file called temp wave.wave, and that file will be an isolated storage file stream. All right, so now it's ready to accept data, and all we'll need to do is go audio stream dot write, and we're going to write the data. We're going to pour the data from our bytes var into this new file. So since this is an array of bytes, we get to tell it where we want to start dumping the bytes at position 0 and all the way to the end. So we want the entire WAV file, not just little portions of it, okay? So that's what we'll do here, from 0 to the entire length to the end of it, and that's all we'll need to do here, like so. Great. All right, so hopefully that's enough of an explanation to help you move forward. There's a lot going on behind the scenes here, but as a practitioner, I don't have to understand all the underpinnings of how something works in order to enjoy the benefit of getting to work. I just need to know, how am I going to create a file and how am I going to put bytes into that file and then save that file to the isolated storage on my phone. If I can figure that part out, then I can continue to move forward. I can spend, days, weeks, months learning how it works under the hood. That's not important for my purposes today. All right? So after I get that, what I'm going to want to do is set it up to be played by a media element. And so we'll do that next. I just want to remind myself where I'm intending to put that, okay? Okay, so the next thing I'm going to want to do is go over here to our recordaudio.xaml file, and I'm going to add a media element. I'm going to add it right here beneath the content panel grid. So media element, we'll give it a name, and I'm going to also set its autoplay equal to false, and I think that's all I'm going to need to do for now. And then back here at this spot in our save temp audio, we're going to want to go audio player dot set source, and then we're going to pass in the audio stream because it represents a file. And so we're going to, now that we have that file, we can give it to the audio player to play back. We're not telling it to play back just yet. We're just setting its source attribute, right? Okay, so now we're ready to play the sound file. We just need to wire up the event for the play button. So let's go ahead and go over here to our play button, and we're going to add a new click event. So when this is clicked, I want to play audio click. Great. I'm going to right click and navigate to the event handler. There we go. And audio player dot play. Great. Okay, so we've got it all wired up, almost completely wired up here. One last thing I need to do is I'm going to add the call here to the save temp audio, and we're going to pass in the recorder's buffer. Great. Okay, so again, we've got it pretty much all wired up. It's not pretty. In fact, it's very fragile at this point, I suspect. We could easily break the app if we really wanted to. But we'll comb back through this a little bit later, and we will add some defensive code and try to ensure that it doesn't crash under typical circumstances. Again, we'll do that later. For now, what I want to do is test the app. We've written a ton of code here, and that makes me a little bit uncomfortable. I'm always a little bit worried when I write a lot of code and I haven't tested it in small little chunks. But unfortunately, that's due to the nature of the functionality that we've created here. I mean, it wasn't possible to test this in small parts. How do we know that we've adequately saved a file if we can't play it back? Or vice versa, right? So we had to implement it all and then test to see where the problems pop up. So that's what we're doing right now. All right, so this first time through, I almost expect there to be problems with the app. I guess that's a pessimistic way of looking at things, but then I'm not disappointed when things don't work out for me. So let's go ahead and run the app. And let me also say that at this point, you should make sure that you've got a microphone set up with the computer and you know that it works. You could chase down a perceived problem for a half hour and then come to realize that you didn't have your headphones set up correctly in the first place. Trust me, I figured that out the hard way. Okay, so we're going to go to the record, and then I'm going to click the record button, and then what? Well, I anticipated problems, but it just basically bailed out of the app. We haven't seen this happen before. All right, there's a good explanation for this. When you click record, one of two things will happen. Either the app disappeared silently, so you get no error message at all, or you're going to get an exception, and that will depend on which version of the Coding for Fun toolkit that you're using. This is a known problem with it today as I'm recording it, and Clint intends to add a more descriptive error message in the future that lets you know where the real problem's at. Okay, the reason why this doesn't work is because we don't have permission. Our app does not have permission to use the phone device's microphone. To request permission to use the microphone, we need to declare a capability in our WM app manifest.xml file. All right. So in the Windows Phone, you have to request permissions to use certain device capabilities. One purpose of this is to notify the user just how we intend to use their device. They might grow a little suspicious if our app wants to use their geolocation or their camera when that's not the purpose of our app. Our app is just a music player or something along those lines, right? So the way that you ask for permission is that you go to the WM app manifest.xml file and you declare the capabilities of your app. And then that will notify the user of what this app needs to do on your phone, and they can decide whether to allow it or not. So in the capabilities tab, we want to look for the microphone capability, and we'll just add that, and that should be the only thing we need to do now. If we rerun the app and we go through the same set of steps, it should work. Now, again, to actually record a sound in the phone emulator, you need to make sure that you have a working microphone hooked up to the computer. You got to make sure the mic works prior to starting this so you can verify that it's not the source of the problems that you might encounter. Let's go ahead and click the record button, and let's go ahead and start. This is a test just to see if this works. This is a test just to see if this works. Okay, I got it. I heard it on my microphone. I think you probably heard it in the video recording if I got it all set up correctly. So it works. All right, we have it saved temporarily to isolated storage, and now we can then in the next lesson or two we'll ask if they want to save it, and we'll give it a name and all that kind of stuff. But at any rate, all right, that was quite a bit of work. I think the biggest issues with our app at this point is that, first of all, the code is pretty fragile and it's going to be easily broken. And so, for example, if we were to click the record button and then click the play button, I think we could probably break it or we wouldn't get the intended results. Let's go ahead and just stop the app right now. And then secondly, we don't really have any visual feedback to let the user know that that we're currently recording, and if something did break, why it broke. All right, and then the third issue I just referred to a moment ago, we're not currently saving the sound permanently. We're not allowing the user to select a name for the new sound and then add it to their list of custom sounds on the page. So we'll fix all of these issues in due time. For now, what I want to do is focus on improving the quality of the code by adding some defensive programming statements. So first of all, let's go ahead and go back to our record audio. And this is where I want to focus the majority of my effort because there's so much that could go wrong right here. I want to make sure that there's actually data in the buffer before we attempt to create a file and fill it up with the buffer's contents. So the first thing I'm going to do here at the very top, even before this using statement, is if buffer is null, then I want to throw a new argument null exception, and I'll add some text here, some feedback. Attempting to save an empty sound buffer. Now, admittedly, this may not be the best error message for an end user to decipher, so we might want to come up with something a bit more friendly and then log this somehow, or ask the user, or try to correct the problem on our own. But this is a good start. At least we're checking for the possibility of null, and then it will alert the user that something went wrong, and hopefully we catch that during a testing phase, like when we distribute this to our friends or as we're using it on our own time, right? All right, so the next thing I want to do is guard against the possibility that the media element is currently playing when the user taps the toggle button to record a sound. So to do that, I need to change a bunch of things in my code. I need to refactor my code, and what I want to do is create the isolated storage file stream as a private member of the class. So what I'm going to do is start up here at the very top, and I'm going to go private isolated storage file stream and call this underscore audio stream. And now I want to add code that'll determine whether the audio stream is empty. If it's not empty, that means that I have data that needs to be saved, and then I need to empty it out. So while I'm here, I'm going to make sure that the media element is no longer playing a sound and its source property is set to null. So this will release any hold that the media element may have on this audio stream from a previous try. It's possible that the media player will keep a reference to the audio stream from a previous recording, and I want to release that reference before I try to create a new file using the same variable name audio stream. All right, so hopefully if that didn't make sense, you'll see what I mean as we make changes to our save temp audio method here. All right, so let me just write this. Be defensive, trust no one and nothing. Okay, and then here what I'm going to do is clean out the audio player's hold on our audio stream. Whoops, stream. Okay, so if the audio stream is not equal to null, then I'm going to clean it out. So I'm going to tell the audio player to stop. Great. Then I'm going to set the audio player's source equal to null. All right? And then I'm going to call audiostream.dispose. Then what I'm going to do down here in our using statement is I'm going to change this around completely as well. We're still going to, actually I'm going to move this out of the using statement because it doesn't really belong in there. And this is going to stay, but this will change. So I'm going to change this to audio stream equals isostore.create temp file name. So now we're using our private version of isolated storage file stream that can be used throughout all of our methods, not just this one method. And then I'll change this reference as well. That should still work. And then we'll want to change this reference as well, and that should still work. Okay, the next thing I want to do is think about how I create and reference this temporary file name here. I want to make sure not to leave old temporary files around since they could clutter up my app's isolated storage area, much like extra files that take up too much space on our hard drives. So the exception here is that your isolated storage is much smaller than a hard drive, and audio files can be very large, so you could fill it up very quickly. So what I want to do is I'm going to start by moving the declaration for our temp file name up here to the top, private string temp file name, temp file name. I'm going to set that equal to temp wave.wave. Okay. And then next what I want to do is replace this line of code here. Go ahead and delete it. And I'm going to replace it with something like this. Put a little more logic here. If the isostore dot file exists temp file name, then I'm going to delete that file. Isostore dot delete file temp file name. All right, so that should clean up our file name problem. All right, and I want to create a new temp file name based on the time of day that this is being recorded, the date, time. So I'm going to use string.format, and I'll replace out some things about the file name with datetime.now to file time. Great. And so we will call this .wave. So we'll use the replacement code 0, and we'll replace everything between the curly braces right here with the current file time. All right, so this is just a long list of numbers that are separated with dashes that would be suitable to use in a file name. Okay, and I think that's all I really want to do now. So actually, one more thing. I want to disable the play button whenever we're currently recording. So like I demonstrated earlier, we turned on recording and then we hit play, and we don't want to allow that. That simple, what I call state management, should reduce the possibility that the user is able to corrupt something and make our lives as developers easier by eliminating that possibility. All right, so let's do this. Let's go back over here and give this play button a name. We're going to call this name equals play audio. And then come back here and we'll go to save all this. Let's go to the record audio checked. Before we begin recording, I'm going to set the play audio button is enabled equals false. Okay, so that will make it no longer clickable. And then when we stop recording, I'll make it clickable again. So play audio dot is enabled equals true. Great. Okay, so that should help bolster our app, and we can test it out and make sure that these changes work and continue to test it and see if there's any edge cases that will break the app. All right, and I'm sure we could find something. Don't try too hard. All right, so to recap, the big takeaways from this lesson include utilizing the Coding for Fun Toolkit's audio features to greatly reduce the complexity of the phone's microphone usage in order to record a sound. If you want to peek and see what it does, you can actually search for the full name of the class in Bing to find a code listing on on Codeplex, and I was able to do that, and I found this web page on Codeplex where the code is stored, and it gave me some insight into how, for example, the record audio, or the microphone recorder class actually works. So that's an interesting exercise, because it allows you to see how much that Clint's work has done to reduce what we need to do in our phone apps if we want to use the recording feature. All right. We also learned about the other using statement in C# that's used to properly dispose of managed classes that worked with unmanaged resources. We learned about the function of buffers as a means of collecting data at one rate that could be processed then at a different rate. We used the buffer built into the Coding for Fun microphone recorder class, and we retrieved the buffer to save it into a file on the device's storage. We learned about isolated storage and how it protects each application's storage area, keeping it private from the other apps on the system. And we briefly learned about extension methods. We used one that was implemented by Clint in the Coding for Fun Audio Helpers namespace. And finally, we practiced some defensive programming techniques to ensure that our app can handle some unique situations or edge cases. And there's plenty more that we could do there as well. All right, but that's enough for now. We'll see you in the next lesson. Thank you.